Hello, welcome to Learning Beyond. Uh, and we have already started our structural engineering knowledge series. And today in our video, we will learn the two-way slab analysis concepts. So all of you know that in structural engineering, there are a lot of things we need to learn. That means analysis, design, drawings, and site-related issues. So to start with, I will explain about the two-way slab concepts regarding the analysis. Theoretically, then with respect to IS code, and then we will discuss on the practical drawing study also. So first question is what is meant by two-way slab? So let's discuss on this. So let's take an example of one slab. So let's see what is meant by two-way slab first. So two-way slab, there are two conditions for two-way slab. So one is that for two-way slab, there has to be beams on all four sides. Beams should be on four sides. So you can see here, these are 1, 2, and 3. You can say that there is a column here for just understanding the practical aspect. So there is a column, then the beams are supported on the columns, and there is a slab. Let's say the dimension of this slab is 4 meter by 4 meter. Now, first condition for two-way slab is beam should be on four sides. Okay, for just matter of understanding, let me consider this as a 6 meters. Okay, 6 meters. And second condition is that Ly upon Lx should be less than 2. Okay, less than or equal to 2. Ly is nothing but longer span. So in this case, it will be Ly is 6 meter, longer span, and Lx is shorter span. So if you consider this problem, then Ly is 6 meter divided by 4. So the number is, how much is this? 4, 1.5, which is less than 2. So it is two-way slab. So these are the two conditions for two-way slab. We are only trying to understand the concepts of the analysis in these sessions. And in some other sessions, we will see the design also. Now that means it is a two-way slab, and it is generally denoted like this because it is spanning in both the direction. So as it is having a two-way slab, then it will bend in the two directions. So let's say, and it will bend in both direction, and there will be bending moment in both the directions. So it will be, I will show that in plan. So this will bend along y direction, that is longer span direction, and it will also bend like this along shorter span. Okay, so there is a two-way bending, and that's why it is a two-way slab. Now this bending, assume that all the beams are, this slab is simply supported. So assume simply supported. So what is simply supported, what is fixed, we will see. So simply supported. So as it is a simply supported, all of you know that the bending moment at the end will be 0. And again, here it will be 0. And then there is a moment here. So if you see this bending at the mid span, that is along y direction. So it will be my, that to mid span moment. And then this shorter direction, it will be mx, which is mid span moment. But it is along the shorter direction. So this is mx is the short span moment at bottom, and my is long span moment at bottom. Okay, so then all of you know that whenever we calculate any bending moment, so in general, we, let's say one-way slab, what we do, one-way slab, which is simply supported, the bending moment is nothing but WL square by 8. Okay, so if you see this, and WL, L is the shorter span, Lx. Okay. Now L square by 8, let's say this is nothing but 1 upon 8 into WL square, Lx square. So 1 upon 8 is nothing but 0.125 WLx square. So this 0.125 is nothing but a coefficient. which we generally denote as a alpha. Alpha. Okay. As this is shorter span moment, it will be alpha x. So in the similar fashion, for two-way span and two-way slabs, we will have two moments. One is mx and second is my. So mx is nothing but there will be some coefficient alpha x into WLX square. And this is your short span moment. And my will be alpha y into W. See, this is also LX. It is not my. This is not y. This is LX. So we will see that which is given in the IS code. You can see here. I will show you the IS code clause. Okay. So this is your IS code. MX is alpha x WLX square. My is alpha y WLX square. LX is the shorter span. Okay. Now again, we will see this. So LX shorter span, keep in mind. So, but moment, this my is long span moment. So mx, now in our case, it is simply supported. So at the supports, the moments are 0 and the moments are at the mid span, maximum moments. Now, this is a case of simply supported slab. Now let's consider the fixed slab. So let's assume we have a fixed slab. So what is meant by fixed, and that we will see that. First of all, let's say this is a slab supported on the four sides. Assume the dimensions are same. This is 4 meter, this is 6 meter. But now in this case, I am assuming this as a fixed support. Okay. So these are fixed in all direction. And whenever it is a fixed, all of you know that there will be moments at the support also. Let me show both the moments. This is your Ly, longer span, Lx, shorter span. And then moment will be there. So here again, as it is a fixed support, then it will have a negative moment here. Then positive moment. So this will be your bending moment diagram for longer span. Then again here, there will be negative moment, then positive moment or sagging moment here. This we call it as a positive and this we call it as a negative. That means we have a moment at mid span. This will be my as it is a longer span, and my and mid span, mid span, and that too positive, we can say positive because it is at the bottom. This we consider as a positive. This is a support moment which is negative. Again, it is my, but it is support moment, this one, and it is a negative. Similarly, for short span, this will be mx support, and that too negative. This will be mx mid span, positive. Okay, this one. Again here, same mx negative, mx negative. And here also this one will be my negative. See this, my negative. Same, both the values are same. That means in this case, there will be, if you want mx mid span positive, then there will be some alpha x WLX square. So let's say it is alpha x 1 or whatever you want to say, alpha x1, or you can say mid span. So alpha xm, let's say, okay, for understanding. Then there will be, you know that mx short span moment, but it is a support moment now, which is a negative. Here you can see this hogging moment or negative moment, we can say shorter span. It will be alpha x, let's say support WLX square. So there are two moments now in this case. In simply supported, we have seen that there is only one moment at the mid span because the support moments are 0 due to simply supported condition. Here, as it is fixed, so there will be two moments in shorter direction. So this is your shorter short span moments. Then again for longer span my, there will be two moments, my mid positive. Now in this case it will be alpha y, let's say mid wl x. See x, this remains same. My support negative, alpha y support WLX square. Now this alpha x and alpha y depends on the ratio of Ly upon Lx. So actually this is long span moments. And alpha x, alpha y depends on Ly upon Lx ratio. Ly is the long span and Lx is short span. Now, in practice, there will be different dimensions of slab. It's not necessary that it is 4 and 6. It may be 4 and 4, 4 and 5, 3 and 5. Any number will be there. We need to, so that means we can say that Ly by Lx will be different for different slabs. That means alpha x and alpha y will be different for different slabs. So these alpha x and alpha y values are given in the IS code in this table. And there are different conditions also as per the boundary conditions or supporting condition of the slab. So we will see that also in detail. Now here you can say short span coefficient alpha x, which depends on Ly by Lx ratio. And here you can see negative moment at continuous edge, means support moment. Negative is support moment. And there is a positive moment at mid span, whatever. So this is a short span, that means alpha x. And there is a long span also. Here you can see alpha y, and that to negative and positive. So 2 alpha y negative positive and 2 alpha x negative positive. Now we will take one example to understand that what are the alpha x and alpha y values for that problem. And then we will see the different conditions, because there are total 9 cases in this IS code, depending on the boundary condition of the slabs. So for example, let's, for the time being, we will take one simpler example just to understand. So let's say we have a 2A slab. So 2A slab, all of you know that assume both dimensions are same, 4 meter by 4 meter. So Ly by Lx will be 4 upon 4, which is 1 less than 2. It is 2A slab. And also there are beams all around, all the 4 edges. Now in this case, we know that we will have a moment and assume that this is a fixed one. Okay, all ends are fixed. So what is mean by fixed, we will see. So this is our problem. And we know that there will be moment in both the directions. So as in this case, Ly and Lx are same. So shorter and longer both are same actually. So this will be, let's assume this is a Ly, for example, and let's assume this Lx. So it will be alpha y here, support, alpha y midspan, and alpha y support. Okay, so moment will be there. M y support, M y midspan. Okay, so what are those values? And again, this in the shorter direction also it will have the same values as we have seen. So how to do that? So there will be moment mx, that is shorter span, at the midspan, which is nothing but positive value, which will be alpha x midspan, which is a positive value, into WLX square. Okay, then there will be mx support negative value, alpha x support, let's say this will be negative, and WLX square. Now let's see this in the IS code. So alpha x positive I want. And we know that Ly by Lx is 1 here. Ratio is 1. Okay. So here you can see Ly by Lx values are given here 1, 1.1 and this. So that means in our case, this is our Ly by Lx ratio. Okay. That means you need to look into this. Now let's say actually that fixed end all, if the all edges are fixed, then this is the case, interior panels. Okay. We will see in detail all the cases, but here I want to show. So this is your fixed end condition. Interior panel means all edges are fixed. Now here negative, so we are interested in alpha x now. This is alpha x. So here negative alpha x is this and positive alpha x is 0.024. So positive will be 0.024. Positive 0.024 into WLX square. So LX, you know that it is a 4 meter, and W will be loading on the slab. It may be dead load, live loads and all. Okay. Again, see the MX support. So alpha X negative value. So alpha X negative is 0.032. So 0.032. WLX square. LX will be 4 here. Again, MY midspan, that is positive. Alpha Y midspan WLX square and MY support, which is negative. Alpha Y support WLX square. This will be positive value. This will be negative. What are those values? Alpha Y means long span. Y is long span. So here you will see long span coefficients. Long span, right? Alpha Y. So it is first is positive. Positive value is here 0.024. So it will be 0.024 WLX square, and again negative value is 0.032, negative moment. Okay, 0.032. Okay, so that is the two-way slab and how to use the alpha x and alpha y coefficient from the IS code. Now next session we will see the different criteria, that is the load cases. 1 to 9 cases are there in the IS code, you can see here. So we will see that in the next session. So thank you all for watching this video, and for further videos you can subscribe our channel. So thank you all.